Hello AP Calculus students, it's Mr. Ford here with another summer packet tutorial, and today we're looking at topic U, solving trigonometric equations. This is the last trigonometric topic of this packet, and this is going to be kind of a different twist on the same things we've looked at in the previous videos. For these equations, we are actually going to get like answers because what we're doing here, it's right there in the description, we are solving equations. It's probably silly to point out at this stage in the game of your mathematical career, but you know, you're never too old to be pointed something, have something really simple pointed out to you. But this is an equation. An equation is two quantities, one on this side, one on this side, but they're compared to each other using an equal sign. And what we're looking for is what inputs for x will actually make these two things the same. Now, since we're dealing with sines and cosines and tangents today, I have right below me, I have the unit circle, which is always a good idea to have at least a sense of. You don't have to have it memorized so much as you have an idea of how it works and how as you rotate around, because the input value is the angle on the unit circle and the output is, well, if you're looking at sine or cosine or tangent, it depends on what you're going to get out of that particular point, but it's good to have it right down there. Now, a good amount of these questions you can answer on this worksheet. A lot of these questions you can answer by just thinking about it for a minute and honestly guessing and checking down below and finding some x values or some angles that work. However, I will point out that a lot of these are going to have way more than one answer. Some of them will have 5 or 7 answers. The good news is that we are solving them on the interval from 0 to 2 pi, which is also probably worth talking about for a moment here also. This encompasses one rotation on the circle. Since our circle starts at 0, maybe if I draw a picture here, you always start at 0 and rotate counterclockwise until you've hit 2 pi. Now, since 0 and 2 pi are actually the same thing, the same angle on the circle, you'll notice that 0 is included, but 2 pi is not included on the interval notation there. That's because we don't need to include 2 pi. We've already included it since 0 is equal to 2 pi. It's worth mentioning that all of these equations we're dealing with today actually have an infinite number of solutions because you can keep rotating around the circle any number of times and keep hitting those same spots along the circle that make the equation true. However, we only care about one cycle's worth of answers, which is why our answers actually be a lot simpler than they could potentially be. So that's probably enough yammering at the top of this video. Let's actually get into it. You kind of notice that I like starting these videos with a little bit of what we're thinking about before we show you how to do it. So that's going to be consistent with how the class runs in the when we get there in the fall. Also, all the year, we'll usually start by talking about the big ideas and then put them into practice right away. So we're looking for where sine squared of x is equal to sine of x. Now, we could guess and check this. However, we're going to use a little bit of algebraic muscle here to move things around. First of all, we're going to do a strategy we've done a lot of times. We're going to move the sine of x on the right to the left side. So we're going to rewrite the equation like this. Sine squared minus sine equals 0, like that. Sine squared of x minus sine of x equals 0. Now that we got that done, we're going to use the same trick we've used a lot of times. Since we have an equation on the left that equals 0, we're going to try to turn this subtraction problem into a multiplication problem by factoring something out. Both of these terms have sine involved, so let's factor out sine. And see, now we have a product of two things that equals 0. So now that you have two things multiplied together whose answer is 0, that means that one of them has to be 0. So we should consider both cases. There's the case where sine of x equals 0, and there's also the case where sine of x minus 1 equals 0. And a lot of you might be able to do that little algebra step and say, okay, when does sine of x equal 1? And that turns this problem into a pretty easy little thought experiment. When is the sine equal to 0, or when is the sine equal to 1? Just remember that the sine is the y value, or the vertical, as you rotate around the circle. So where does sine equal 0? Well, that happens when x is equal to 0 and when x is equal to pi. And sine of x equals 1 at only one spot, pi over 2. Unfortunately, 3 pi over 2 is out. 3 pi over 2 would make the left side of the equation positive 1, but the right side of the equation negative 1, if you're looking back at the original equation. If you think about those three angles in that original equation, those all will work. The 0 and pi will give you 0 on both sides, And the pi over 2 will give you 1 on both sides. Those are the places where sine squared equals sine. It's worth mentioning that anytime you add 2 pi to any of these answers, you get another answer. So a lot of times, I'll only mention this in this one problem, and they'll move on. A lot of times, if they didn't give us the interval up here, we'd have to express our answer in some sort of way like x equals 0 plus 2 pi k, x equals pi plus 2 pi k, and x equals pi over 2 plus 2 pi k, where k is an integer. Just to express the idea that you can start at those 3 points along the circle, at 0, at pi, and at pi over 2. If you rotate one full rotation, you'll land at the same spot. So those are the 3 spots in the circle that work. That's the last time I'll do that. So there we go. All right, let's try number 2. 3 tangent cubed equals tangent of x. We're going to do largely the same thing in this problem that we did in the previous one. Start by subtracting that tangent to the other side, set it equal to 0. Now we can factor a tangent out just like before. Careful on that second term. That is 3 tangent to the 3rd power. So we have 3 tangent squared left over in that right term. And of course, now we need to consider the places where tangent of x is equal to 0. And we also need to consider the places when 3 tangent squared of x minus 1 equals 0. Now, tangent is a little harder to think about since tangent is itself kind of a function here. Tangent is usually thought about as the sine of sine over divided by the cosine, or sometimes the y over the x, if you want to think about it that way, since sine is the vertical and cosine is the horizontal. So if you're looking for when well, that actually makes this a little easier, because if we're looking for when the tangent is equal to 0, well, cosine can't be 0 because that would make it undefined. So we're really looking for where the sine is 0. So I think it's worth mentioning that tangent is 0 whenever sine is 0. And so we're going to have pretty much the same answer to that part of the question we had in the last one. It's going to happen at 0 and pi. Tangent is 0 when x is 0 or pi. There is the first part of our answer. The second part is going to be a little trickier to answer than we thought before. So let's at least do the math here. Now on this 3 tangent squared minus 1 equals 0, we can start by adding the 1 and dividing the 3, and that gives us this equation. Tangent squared of x equals 1/3, which if we do the square root gives us, okay, tangent of x is equal to plus and minus 1 over the square root of 3. Now that is not a thing that's very obvious if you're looking at the unit circle. It doesn't really pop up. You don't see 1 over the square root of 3 anywhere. So what we need to remember is that tangent is equal to the sine over the cosine. So what we're thinking about now is what sine divided by what cosine would give us plus or minus 1 square root of 3, like this. Now, if you think about, if you start playing around with some of these x and y values, what we're looking for is a place where the top of the fraction is 1/2 and the bottom of the fraction is the square root of 3 over 2. Now, the way I like to think about this, I'm just going to map this out for you, is that is 1/2 times 1 on top and 1/2 times the square root of 3 on the bottom. And the 1/2s can now cancel out, leaving the 1 over the square root of 3. So we're looking for angles whose y value is 1/2 and whose x value is square root of 3 over 2. Now that happens, I see one of those right away at pi over 3. And again, I wish I could highlight the picture underneath me, but I cannot draw on it since it just exists as part of this program. But hopefully, if you're looking at the unit circle, that is the first one. That's where the y is 1/2 and the x is the square root of 3 over 2. Now, that happens again on the other side of the circle, way down at 240 degrees, or 4 pi over 3. At 4 pi over 3, what you get is negative 1/2 over negative square root of 3 over 2, but that is the same positive 1 over the square root of 3. Oh, that kind of got cut off there. I forgot what my zoom situation is. So at 4 pi over 3, even though they're both negative, it still works. So there's 2 answers, pi over 3 and 4 pi over 3. I think I got that right. Oh, shoot. Sorry. Oh, man, I wish I could edit this. I am so wrong. I'm so wrong. Erase all of this. Oh, I got the x's and y's flipped around. I'm looking for, what I want is pi over 6. Sorry. Some of you guys are probably watching this video and going, oh my god, Mr. Ford's an idiot. Pi over 6 is the one I'm looking for. Sorry. Pi over 6 has a y of 1/2 and an x is square root of 3 over 2. 2. And then across the circle from it is 7 pi over 6. 7 pi over 6 is the one I'm looking for. Sorry. Pi over 6 has a y of 1/2 and an x is square root of 3 over 2. And then across the circle from it is 7 pi over 6. 7 pi over 6 is the one I'm looking for. Sorry. Pi over 6 has a y of 1/2 and an x is square root of 3 over 2. And then across the circle from it is 7 pi over 6. So these ones, both of these will give you a positive 1 over the square root of 3. However, we also need to remember there's a plus and minus going on here. So there's also the idea this could be negative. So same game, when is y 1/2 and x square root of 3 over 2, but one of them is negative and one of them is positive. That happens at 5 pi over 6, where you have, if I'm looking at the unit circle correctly, we got positive 1/2 on top and negative square root of 3 over 2 on the bottom. And that, again, will divide out to be negative 1 over square root of 3. And that happens again over at the other side of the circle at 11 pi over 6. So there are 4 answers to this question, I believe. We have 0 and pi from tangent equals 0, and we have those 4. Pi over 6, 7 pi over 6, 5 pi over 6, and 11 pi over 6. I suppose you could put them in order if you wanted to be a nerd, but who cares? Ugh, sorry about that. I made a mess in the middle of the video, and I do not edit these. I just kind of go it and do it in one go. So I'll put a thing in the description about how I make a mistake in number 2, so don't sweat it. Okay, let's talk about number 3. When does sine squared of x equal 3 cosine squared of x? Well, this is a challenging problem because we've got sine and cosine together in one problem. Now, a good trick, whenever we're dealing with a problem like this, a good thing to do would be to reframe the question by replacing sine squared or cosine squared with an equivalent expression that involves the other one. That sentence didn't make any sense, except to me. But here's the thing. If you've been around a trig class long enough, you're probably aware of this identity. This is the only identity that is worth memorizing out of your trig identities unit from pre-calculus. Sine squared plus cosine squared equals 1. This is the one that you should know. Again, I hate the word should, but this is the one that you want to know. Good advice from a guy who's been doing math for a long time, because if you do one little algebra step, you get a couple of quick identities that will easily allow you to switch out sines and cosines. If you subtract cosine squared from both sides, it can be easily demonstrated that sine squared is actually equal to 1 minus the cosine squared. And if you were to subtract the sine squared from both sides, you could easily replace the cosine squared with 1 minus the sine squared. These 3 are all kind of the same idea. And so the top one is worth memorizing, and it's also a good idea as you're memorizing that to remember the other 2 down below. That's exactly what we're going to do here. We're going to do exactly that and then transform this problem. It's pretty much exactly how we've been doing it before. In fact, the first thing we're going to do is move that 3 cosine squared to another side. So let's start by subtracting that over. And now we're going to replace the cosine squared with the 1 minus sine squared. You could do this with the sine squared also. It doesn't really matter. So we have sine squared of x minus 3 times 1 minus the sine squared of x equals 0, like that. So all we're doing here is replacing cosine squared with 1 minus sine squared because they are the same thing. From here, we're going to treat it pretty much the same way as any one of these other problems. We're going to let's do some distribution and combine some like terms together. We have currently sine squared of x minus 3 plus sine squared of x equals 0, and that is going to give us, plus 3. I forgot about the 3 there. And when we combine our like terms together, that gives us 4 sine squared of x minus 3 equals 0. And we can't play the factor game in this problem the way we could in the previous 2, but we can, since there's only really one x here. Let's just try solving it for x like we would normally. Let's first add the 3 and divide the 4 over. So sine squared of x is equal to 3 over 4. And now, when we take the square root of both sides, what we get is sine of x is equal to the plus or minus square root of 3 over the square root of 4, which is 2. And this is a nice thing to stop at because all we're looking for is the angles who have a sine value of positive or minus square root of 3 over 2. And at this point, you're done doing math. All you got to do is look at your unit circle or consult the one that lives in your mind and remember which angles have that y value. I see 4 of them. The first one is pi over 3 with a y value of positive square root of 3 over 2. And its partner, 2 pi over 3, which also has the same y value. You can draw a horizontal line. And then we have 2 down below, 4 pi over 3 and 5 pi over 3. Those are the ones that have that y value on the bottom half. There you go. Again, these 2 are positive, square root of 3 over 2, and these 2 are negative, square root of 3 over 2. So there are 4 answers. And there you go. You could try plugging those back into the original equation if you wanted to check it, but let's move on to this next one. Now, number 4. Again, this looks like one of those. Again, we have sine, cosine, and tangent in the same equation. That's frustrating. I think the first goal will be to make this all 1. So we're actually going to kind of think about this as a trig identities problem first before we try to do any math with it. Let's at least put everything in terms of sines and cosines. And by that I mean let's just take this tangent and let's rewrite that as sine over cosine. Again, with a problem like this, there's probably like 4 or 5 different ways to think about it. Probably more than that. So, you know, my advice to you in pretty much every math problem from this point forward is try something. Even if you're wrong, you'll learn something about the problem that you're doing with. So don't spend too much time debating on what strategy to try. Just try something. And then you'll find that if you can take that first step and write it down, you might, okay, now I see where a next step might be. In this case, we can multiply those two things together. This is sine squared over cosine. And we can actually add these two things together by rewriting the one on the left. We can multiply it by cosine over cosine, which is the same as multiplying it by 1, so it's okay, we're not breaking any rules. This gives us cosine squared of x plus sine squared of x all over the common denominator of cosine equals 2. And you might see exactly where that's handy because bam, right there. Sine squared plus cosine squared equals 1. Because you memorize that one, the only one worth memorizing is sine squared plus cosine squared equals 1. So let's do that. So now we get a pretty easy problem. When does 1 over cosine equal 2? And that's not too easy on its own, but what you can do is take both sides of the fraction and flip it. And so really this question is, okay, when does cosine equal 1/2? And that's a much easier question to answer. Because remember, cosine is just the x value. So what angles have a cosine value of 1/2? I see 2 of them right now. The first one is at pi over 3, where the x is 1/2 and the y is root 3 over 2, and 5 pi over 3. Remember, if you're looking for the same x value, you're kind of drawing a vertical line through the graph. So pi over 3 and 5 pi over 3 are on the same vertical line on your unit circle. And those are the only 2 answers that I'm aware of for this problem. Let's take a look at, probably, in my opinion, the easiest question here is number 5. When does sine of x equal cosine of x? This is less of a math problem and more of just a mental challenge. Now, you could do one algebra step and divide cosine on both sides, and that would give you this question. Sine of x over cosine of x equals 1. Or tangent of x equals 1. These 3 questions are often the same. For calculus, this is actually a really good question to be able to answer on the fly. Remember, if you're ever asked when tangent of x is equals 1, you're really asking, okay, when are sine and cosine the same thing? So remember, if sine is the x value and cosine is the y value, where are those 2 things the same? There are only 2 places on the unit circle where that happens. The first one is at pi over 4 in the first quadrant. That is where they both have the value of root 2 over 2. And that happens again in the third quadrant at 5 pi over 4, where they both have negative square root of 2 over 2 for the coordinates. And that's an easy question. Not really a whole lot of math to do on that one, just checking for places when the x value equals the y value. Might be worth a good note to write down. When does y equal x? It's also worth mentioning that if you were to draw the line y equals x on your unit circle, it would pass through those 2 angles. So, okay. And let's look at one more. I got to be honest, I hate this kind of question, but we're going to do it anyway because we have to, because it's just part of this packet. This is going to involve a quadratic formula. So, well, maybe not. I think we can get around it. We're going to use the same strategy we used in number 3 on this one. We're going to replace the cosine squared with 1 minus sine squared. And maybe you already recognize kind of the quadratic nature of what we've got going on here, but we'll talk about that in just a moment. So let's go ahead and distribute the 2 and clean it up a little bit. 2 minus 2 sine squared of x plus sine x minus 1 equals 0. Let's see, that gives us negative 2 sine squared of x plus the sine of x. 2 minus 1 is plus 1 equals 0. Pretty cool. Now, maybe you recognize the quadratic nature of this expression. This is very much a good idea. Let's just draw a little thought bubble off to the side here. This is an ax squared plus bx equals, or plus c equals 0. That's what we got here. It just so happens that the thing that we're squaring is sine of x. I think in this case, if you called a negative 2 sine and b sine, then you'd be, and c was equal to 1, you'd have a quadratic formula. Now we could plug this into the quadratic formula and maybe even get an answer, but I think there's going to be a better way for us to handle this. The first thing I'm going to do is really kind of nitpicky. I'm going to go ahead and multiply everything by negative 1 so I can change that, because I hate when my a term is negative in the front, so I'm going to change the sign of everything. I'm going to make this positive 2 sine squared of x minus the sine of x minus 1 equals 0. So we're really just multiplying everything by negative 1 there. And I don't know why that 2 came out red. Whoops. Now, if this looks strange to you, what we're about to do, what it might be helpful as kind of a sidestep here is that I'm going to call the sine of x, I'm going to call that a. Big capital A. And what that does is I can rewrite the problem like this. What you have is you have 2a squared minus a minus 1 equals 0. And that might look a little more familiar to you, because what we're going to do in the next step is factor it like we would normally. We're going to think, okay, I need 2a and I need 1a right there. And I need something that multiplies to negative 1, so plus 1 and minus 1. And you got to strategically place those so that the 2a squared comes out positive and that comes out negative. So I think this works. No, it doesn't. Did I do this wrong? No, I'd have to make them both. Hang on. Stand by. Gotta think. This gives me 2a. Oh, I'd have to make it. I'd have to make this minus 1 over here and this plus 1 over here. Okay, got it. We're good. That gives us 2a squared minus 2a plus a minus 1. Okay, yeah, it works. So well, sorry, brain fart there in the middle of this problem. But there you go. We're going to factor it. Now, when we factor it over here, it's going to look a little different since a is equal to the sine of x. But it's basically going to look pretty much the same. You have 2 sine of x plus 1 times the sine of x minus 1 equals 0. And now that you got it factored, now you can solve it, because you have two things that are multiplied together whose answer is 0. And that only happens if one of them is 0. So case number 1, what if 2 sine of x plus 1 equals 0? Well, that would mean that sine of x is equal to negative 1/2. And again, if you're looking at the unit circle and thinking, okay, when does the sine or the y value hit negative 1/2? That happens at two places, 7 pi over 6 and 11 pi over 6. So there is the first pair of answers. The other pair, which I will do in green, I suppose, is when is sine of x minus 1 equal to 0? Or in other words, when does sine of x equal positive 1? Now there's only one answer to this one, and that is at x equals pi over 2. And so there is your three answers to this question. Pi over 2, 7 pi over 6, and 11 pi over 6. Hey, we made it. See, you can do hard things. You are so capable of doing this math. You got nothing to worry about this coming year. You've got it all under your belt. You're strong enough. You are smart enough. You got it. There's nothing going on here that generations of human beings before you have not figured out. You can do it. You're standing on the shoulders of everybody who came before you. Really proud of you for taking calculus next year. It's going to be a lot of fun. Anyway, before I wrap up this video, just got a quick note. The next video is the last one in this series, but I might actually do it as a two-parter, and it's all about calculators. So the last video in this series will be about finding answers on calculator. I'll be doing one probably in Desmos, and then I'll do another one with the TI-84, which is the standard tool we use. Hey, you got this. You are awesome. You are intelligent. I hope you're having a fantastic summer. And I can't wait to see you in the fall. Can't wait to get back to work at school. And I will see you in the next video.